how are you? In today I'm going to discuss about the experiment related to eye. In previous video I discussed about the what is the eye, parts of the eye, structure of the eye, then the process of visionary senses. In today I'm going to do experiments related to eye. Okay, let's see. Okay, now you can see a diagram. This is the refraction of parallel beam of light rays through the convex lens. Okay, let's discuss about it. Okay, now if you think there is you have to see a thing. Let's get like a candle. Okay, then from that object light rays are refracted. Then you can see a lens. This is the convex lens. It's similar to our lens which is in the eyeball. Then the light rays are going through that lens. Then after that the light rays are collected to one point. It means the eye lens is the convex lens. That lens is similar to our lens which is in the eye. Then you can see the light rays are collected to one point. This is known as the focus. This is situated in front of the convex lens. Then this focus is similar to our fovea. Now you can obtain what is that experiment. Okay, let's see the refraction of parallel beam of light through the concave lens. Okay, now you can see this. Okay. Like that there is a candle, then from that candle light rays are releases, but that light rays get diverged after refraction. Then that focus on that concave lens in the parallel beam of the light is imaginary point, and the light rays also imaginary lines, because in concave lens there have not any focus. Then this is the imaginary line. Then the light rays after refraction appear to come from a point called the focus. Then the length which is between the lens and the focus is known as the focal length. These are the parts of concave and convex lenses. To get a clear image, we have to change the image distance. Okay, but you know, in our human eye, image distance cannot be changed. So what we have to do? We have to change the curvature of the lens according to the requirements. Okay. In human eye, distance between the lens and the retina cannot be changed. Okay. It means the image distance. So by changing the curvature of the eye, lens distance object and nearby object both can be observed. Okay, the ciliary muscles are help us to change the curvature of the eye when it is necessary. The curvature of the eye lens should be reduced for the distance object. For seeing the distance by object, we have to reduce our curvature of the eye. Then we can see the distance by object more clearly. Then to watch the or see the nearby object, we have to increase our curvature of the eye. So we can see the nearby object by increasing the curvature of the eye. Now you can see the convex lens with a less curvature, convex lens with a high curvature also on the screen, and the focal length of the lens with less curvature is high. It means to see a distant object, the focal length of the lens is high. Then the focal length of the lens with higher curvature is low toward nearby object. Okay, let's see ray diagrams for images formed of objects on the retina of the eye. When obtaining images by convex lenses, image distance can be changed by changing what? The position of the screen. But when making images by the lens of the eye, image distance cannot be changed. So, we have to change the curvature of the eye lens. Then, we cannot change image distance in our eye, no? So, because there is definite distance between the lens and the retina, so we can't change it. By the lens of the eye, two types of images are formed. I told you previously, images of far object as well as images of close object. It means nearby object. Okay, this is the ray diagram to the far object. Then the rays that reach from far object can be considered as parallel rays. It means in that faraway objects, the rays are parallel rays. Then they get refract through the lens and converge onto the retina, making image on it. It means in the fovea, the image is formed by converging the light rays. Then you can see the ray diagram for the close image. It means nearby image. In here, the rays that reach from the close object can be considered as diverge image. These are the diverge rays. They get reflect to the through the lens and converged onto the retina, making image on it. In a faraway object, they are what? Converged image. In nearby object, the rays are diverge rays. So these are the things that I hope to do. I think that you enjoyed my lesson.